And it's largely one loss function taken to a very large amount of, of compute usage. You set up really efficient systems. And then at the end of that, you have this base model. And pre-training is where there is a lot more of complexity in terms of how the process is emerging or evolving and the different types of training losses that you will use. I think this is a lot of techniques grounded in the natural language processing literature. The oldest technique, which is still used today, is something called instruction tuning, or also known as supervised fine tuning. That people really go back and forth throughout them, and I will probably do the same, which is where you add this formatting to the model where it knows to take a question that is like, explain the history of the Roman Empire to me, and or something, a sort of question you'll see on Reddit or Stack Overflow, and then the model will respond in a information dense but presentable manner. This reinforcement learning from human feedback is credited as the technique that helped ChatGPT break through. It is a technique to make the responses that are nicely formatted, like these Reddit answers, more in tune with what a human would like to read. This is done by collecting pairwise preferences from actual humans out in the world to start, and now AIs are also labeling this data, and we'll get into those trade-offs. And you have this kind of contrastive loss function between a good answer and a bad answer. And the model learns to pick up these trends. There's different implementation ways. You have things called reward models. You could have direct alignment algorithms. There's a lot of really specific things you can do, but all of this is about fine-tuning to human preferences. And the final stage is much newer, and we'll link to what is done in R1 and these reasoning models. Is, I think, OpenAI's name for this. They had this new API in the fall, which they called the Reinforcement Fine-Tuning API. This is the idea that you use the techniques of reinforcement learning, which is a whole framework of AI. There's a deep literature here. To summarize, it's often known as trial and error learning, or the subfield of AI where you're trying to make sequential decisions in a certain potentially noisy environment. There's a lot of ways we could go down that, but fine-tuning language models where they can generate an answer and then you check to see if the answer matches the true solution. For math or code, you have an exactly correct answer for math. You can have unit tests for code. And what we're doing is we are checking the language model's work, and we're giving it multiple opportunities on the same question to see if it is right. And if you keep doing this, the models can learn to improve in verifiable domains to a great extent. It works really well. It's a newer technique in the academic literature. It's been used at frontier labs in the US that don't share every detail for multiple years. So this is the idea of using reinforcement learning with language models, and it has been taking off, especially in this DeepSeek moment.